Hello, everyone. Welcome back to another episode of 401 Access Denied. I'm really excited about today's episode because we've got another exciting topic for you. And before I get into the details of the topic, I want to, first of all, my name is Joseph Carson, and I'm the Chief Security Scientist and Advisory CISO at Lycotic, based in Tallinn, Estonia. And I'm joined with two fantastic esteemed guests for the show today. So first of all, I'm going to pass it over to Kevin. Kevin, can you tell us about who you are and a little bit about your background?
Yeah, thanks, Joe. So Kevin Haynes, this is my second month here at Cybrary. I joined on as the CEO. Super exciting, also super exhausted at this point. I spent the last 8 years at a company called SecureWorks, which is a large MSSP here in the U.S. And last 4 or 5 years of that, I was a COO. Lived a lot of the pain points that Cybrary is pointing at, and I'm really excited to be here. Thank you for the
Fantastic.
intro. Yeah,
Fantastic. Thanks, Kevin.
yeah,
And also, we're joined by John. So, John, can you give us a little bit about who you are and a bit about your background?
Yeah, sure. Hello, everyone. My name is John Ramsey. I'm really grateful to be here today and have this conversation. I think it's an important one. Up until February, I was the Chief Technology Officer at SecureWorks, where Kevin and I met for about 21 years, where was on did my whole entire professional career has been in security one way or another. While I was at SecureWorks, I also had a role as a senior Dell Technologies fellow, so I got to go and see the advances and innovations that Dell Technologies and the strategically aligned businesses were doing, which was a lot of fun. Uh, Built out a pretty interesting machine learning system in SecureWorks. Actually, a couple of them to solve a lot of the problems that we have in cyber. Prior to that, I was at the computer emergency response team at Carnegie Mellon University, where I did computer network exploitation, computer network defense. It and while I was there, I studied software engineering at CMU to try to understand why so many vulnerabilities exist. And then prior to that, I was at Siemens Corporate Research, and so thank you for having me. I'm excited to be here.
Fantastic. So this is going to be an exciting discussion today. I mean, between the three of us, we have almost quite a wealth of knowledge and experience behind us. So, and what I've seen is, at your backgrounds, we've come, probably not directly introduced to each other, but we've followed the same paths in the industry. So really excited, kind of where we'll see where this conversation goes. So today's topic for the audience is a really exciting one because sometimes we segue into different areas, such as what we see the cybersecurity industry. It's no longer just about technology. It's no longer just specifically about security because it segues into so many businesses in different ways. And one of the biggest areas as well is we have a major skill shortage. We have a major area of basically we're shortage in people filling the jobs, and organizations are opening more positions, and we actually have people that actually fulfill them. So it causes a major challenge, and we always look for ways of how can we automate a lot of things. And I've seen a lot of areas such as social backgrounds, people with social science skills coming into the industry to really help, bridge that gap between the technology and the human side of things. And that's also seen a lot of people coming even from the psychology background to try and make sure that we're building things that actually people can use, that people can actually understand. So cybersecurity is kind of opening up into to many different new industries. And today's topic is all about the area of data science. And this is going to be an area that, and specifically data science in a security context, because we've seen where people coming in that we need to, I've always been in the industry where we need to automate things. And to automate, we need data. We need good analytics. We need good algorithms. So this is where we really help understand about the direction and path we're going. So I'd like to kind of, Kevin or John, whichever one of you wants to take this first, can you give the audience just a bit of an overview into, what does data science, the background, what's the state of where we are today, and also how important is it for security industry?
yeah. John, you wanna kick that off?
Yeah, sure. I think like Joe said, the security, the disciplines that are coming into security are increasing, and we need it. I think that's really really helpful. And of course, data science is if every other industry is being digitally transformed, we
Mm-hmm.
should be digitally transforming the way we approach cyber. And so, first, maybe if we take a step back and think about what is data science as itself, because there's a lot
Mm-hmm.
of there's a lot of ambiguity around the term of data scientist. So maybe if we can bring some clarity to that, then we can think about how data sciences could help us defend, to be good, better defenders. And so data sciences is a broad term. It generally refers to the class of approaches you use to making inferences or learning effectively from data. It can be broken down from traditional big data with large searches as a form of data sciences to what's probably more uh, recent in terms of evolution in that is it really the area of artificial intelligence. And then underneath artificial intelligence is machine learning, and then underneath machine learning is deep learning. And so sometimes companies will say we're using data sciences, and they mean we're doing maybe statistical anomaly detection as a form of data sciences, but that isn't necessarily machine learning. Underneath that, in the machine learning world, in the deep learning world, there's really, the way to think about it, there's three components that consist of that. And if someone says they're doing AI, ML, or DL, you ask them what are the three components, and the three components are what are your models look like. So this is some representation of the real world, some simplification of the real world, some kind of state-based model, for example. What is the question that you're trying to infer with respect to the model, and how are you learning? What is the learning approach taken from the data? So if you have those three piece parts, modeling, inference, and learning, effectively what you have is a form of artificial intelligence or machine learning. There's lots of different approaches here. And quite frankly, there's a lot of math that exists underneath it. There's predicate calculus, there's linear algebra, there's probability theory. So the discipline that data science is bringing into the cyber realm is really specifically around those disciplines, in terms of linear algebra, predicate calculus, and probability theory.
Okay.
Yeah.
And anything
Yeah.
you want to add to that, Kevin?
Yeah. From my perspective, sitting in my chair, or my last chair, it really boiled down to how do we bring more automation? The word you said. At the end of the day, I'm 100% sure we could not have done our jobs without having some support and assist from the technologies, the data sciences technologies that John and our team built. There just were not enough people with the skills to do that. So we were talking on the order of billions of security events a day, sort of going through our systems, and that's just, you just can't staff that, right? So you got to find a way to do that. The other thing I'd just say, with the new folks coming in, it's always interesting at what point they realize, just talking to them as they kind of come into the company and or get into the field very excited to solve these big data problems and help the world. At what point they realize that there's actually an adversary on the other end of the keyboard who's trying to undo everything that they're doing, right? And it's kind of interesting to see that light bulb come on, because I think in a lot of other fields, it not necessarily the case, right? Not necessarily the case that there's someone actively working against them.
Yeah.
So that's interesting to see when that happens and they realize it.
And it's always about, staying ahead of the curve as well. You always have to try and keep ahead. In the defenders versus attackers, that in the defender side, we have to be successful 100% all the time. It only takes the attacker to be successful once. They only need to find one key to get in the door. So sometimes it's always a challenge. And I always feel that the defenders don't get enough kind of, let's say, reward or visibility or support about the job that sometimes goes unseen in the background. They're spending it. The only time you hear about the bad things is when an incident happens, but you don't hear about the 300 other days of the year where they've been actually working, keeping the company safe. So sometimes it's a bit of always, they're always working in the background, sometimes doing amazing work, hidden, and so a lot of times goes unrewarded. One of the things, kind of, so just kind of on the point of what John was mentioning. So for me, kind of when I look at the industry, and I do research across the board into a lot of companies who are doing a lot of machine. I think machine learning is advancing the quickest. For me, when I look at the artificial intelligence side, I'm still seeing that right now what we're really doing, especially in the cybersecurity, when it comes to artificial, it's advanced much more in other industries than it has in the cybersecurity. But in cybersecurity, I find it's much more still into advanced automation, where we're taking the data, we're doing a lot more automation, but getting into where it's self-learning and self-healing and self-perpetuating, and taking the new let's say threats that's been discovered, and actually then creating defenses to defend against that. I think that's where we start seeing a little bit more trend towards a real artificial intelligence into the security realm, but I don't see that we're quite there yet. Everything I look at is, it seems to be more around the automation side. Can you tell me what, maybe I've kind of different, visibility. Can you tell me what you've seen, or what your kind of interpretation of the artificial intelligence that we have in the security industry today?
Yeah.
Yeah,
You want to start?
yeah. I think I'll jump in on that. I think a couple things about positioning artificial intelligence and machine learning in the cybersecurity space, which is number one, like that it countermeasure development when you learn about a threat. Well, let's step back.
Mhm.
I think diversity is a key characteristic of survivability. And sure, the threat only has to be right once, but I don't really believe that's true. Sure, to get in, they have to be right once, but they have to be right again to get their data out. They have to be right again to the whole kill chain. They have to be right along that process. And so, where I think what we need to detect the threat is we need diversity, and that diversity includes things that have that, like signatures are not dead. They'll never be dead. When we have an indicator of a threat, we should use it. We should use it
Mhm.
against the threat, and we should use it everywhere. We know. But the question becomes, what do you do when you don't have an indicator of a threat? Well, then that's where you start applying, sort of, instead of these representational
Mhm.
techniques like indicators and signatures and hashes and domain names, you start applying more functional areas for detection. So just probability as a means of anomaly detection. So we don't know if we haven't seen this before. It's probabilistically unique. Maybe then it could be malicious. You don't start with that, but you use that to
Mhm.
build context to now all of a sudden building out attack graphs to understand where a threat might be and where they might go to drive sort of the defense process. If you use this diversity of representational and functional techniques to be able to detect the threat, then now you have increased the amount of sophistication in that threat and the time almost exponentially, because they have to be thinking about, how do I defeat these multiple types of systems instead of one type of system. So that's number one. I also think when it comes to AI and ML, there are the approach I would take, or what I step back when we come at the problems. The very first thing we need to do is scope the problem to be as specific as you possibly can. There's this term in the ML world. It's called no free lunch. Like, you're not going to say,
Mhm.
here's the problem, here's the data, here's the algorithm, and you're going to get it. You're going to get results with high efficacy. So really thinking about the scope of the problem, and there are lots of problems that exist in the cyberspace that AI and ML can solve. Just for an example, detection of malicious activity, which we just talked about, or dynamic threat actor discovery. Like, let's use the techniques that are used in social networks to build social networks of threat actors based on shared attributes of TTPs, as an example, or even threat actor attribution inference, building threat actor sets. Today, all those threats are sort of put together because an incident response team walks in and goes, well, this looks like a group. This looks like a group we haven't seen before. Let's create a new group. And, the catalog of threat actor sets is, in the hundreds. There are probably 10,000s of different
Mhm.
threat actor intrusion sets. Also, like, inferred relations among events themselves. Like, today, correlation is sort of done by rule based. But what if we learn that these two events have properties that support the correlation of those events? And then threat intelligence overall, I believe we're seeing an evolution of threat intelligence, or the data that is represented via threat intelligence, moving to more of what a data scientist would call a model, a representation of the world that is much more um, prescriptive. It's much more mathematically consistent. And so you can reason about it, which that's really important. And so model-based threat intelligence is how we need to represent what's happening from a threat perspective. So you roll all of that together, and you can see that there are many use cases that exist for machine learning and data sciences in the cyber domain. Or here I love this one.
Mhm.
Like, there's this whole space called generative adversarial networks, and it's really two algorithms competing with one another. I generate an image, and when I generate that image, I put it up against another algorithm to see if that algorithm can detect the image. Well, why don't we use something like generative adversarial networks to test our countermeasures and efficacy of those countermeasures, and build a system that tries to beat the system? Like that space is also very interesting. So it's just a really exciting time in cyber when it
Mhm.
comes to taking these kinds of approaches and being able to move the needle from a defensive perspective.
Yeah. And Joe, I
Mhm.
think is my perspective on this, which is I would agree, with how you positioned that uh, there's a lot more, I think, to
Mhm.
come in terms of
Yes, absolutely.
things like self healing and sort of taking the next steps here. But I do feel like today a lot of it is automated. It's creating it's all great, right?
Yeah.
It's creating automation. It's helping. At the end of the day, we're still putting a lot. We're still putting a lot on the shoulders of men and women,
Mhm.
in these roles to make pretty tough decisions about a lot of different things with a lot of different nuance in a very short time.
Absolutely.
And so yeah, hopefully we continue to kind of
Mhm.
make progress to make those jobs a little easier.
Absolutely, and that's kind of what I've been in the industry now, getting close to 30 years, and every time I remember that, I always ran out of time, and you never had enough time in the day to do your job. I was a domain administrator for 100,000 servers, so what did I do? I automated. If I had to do
Yeah,
something 2, 3 times, what I did was I created a script. I got something in a batch job. I did a scheduled task. I put something in a Perl script. So I looked at ways in order to scale, and that's what we've done over the years. In order to, we've seen organizations where you maybe had 1 or 2 people managing 100 machines, 100 employees. You had 2 people doing that. Today, we've got basically organizations who have 2 people managing
yeah,
20,000. And a lot of that as well is also balance. And so they can't do everything themselves. They can't be experts of everything. So what they've done as well, they've outsourced where they possibly can in order to continue managing that. They went to service providers. So I think for many organizations, I don't think a lot of SMBs or even medium-sized companies who get to that type of threat intelligence. So I think a lot of that will most likely come from service providers and platforms. So they will have to plug into that. So I think definitely that's the direction. But automation, I think, is the key part here because we have that shortage. In order to close that gap, automation and using data analytics. I remember, working in the early 2000s about even detecting things like memory failures and hard disk running out. That
yeah,
what we'd do is we'd take the last 6 months or last year of data, and you'll see basically memory increasing. And what we could end up doing is try to reverse that data and put it into the future. And that was great because that's when SQL reporting and analytical service started being able to do a lot more things for you in order not just but looking in the past, but also getting into predictability. And we were able to then say, roughly in November, this hard disk is going to run out of space. We need to do something before it runs out because worst case, adding space before it runs out will stop you getting data corruption.
yeah, yeah,
If you wait till the disk runs out, you're going to end up with corruption. So that's kind of where a lot of those trends, and that's for me when I really kind of got even just into the little just getting paddling in the little streams of data science. I've never delved right into it, but I work a lot in the industry people who's coming, and they're doing some amazing things. I watched here in Estonia where there was a data analytics that was done in, for example, just to give you an example use case, is that a traffic lights. So what happened was there was a specific traffic lights where there was a lot of accidents happening. Just a lot of accidents were happening at this specific location. So what they started doing was they started doing some trial runs, and they got basically some glasses that detected eye movements. They wanted to see where people's eyes were when they were going through that intersection. And ultimately, what they did was, after doing a lot of trials, day, night, and so forth, the data that came back from basically the glasses, and they took that data, they analyzed it, they put it into the surrounding view, and ultimately, what happened was that people's eyes were going automatically to an advertisement board. And there was the advertisement board, and ultimately, the root cause was the light was too bright. They dimmed it down. They turned down the light on the advertisement board because they were able to take all of that eye movement, all of that data, and understand about what was causing the issue. When they actually turned the light down and dimmed it down, and it was also kind of different times of day, because in Estonia we have some, in summer the light is very bright low, and when dark, it's winter it's very dark a lot of times of day. So they adjusted it, and afterwards the number of accidents at that intersection reduced down. And I think that's where, when I look at those types of areas where they're using data in order to look at how to understand about its correlation and context, I see that this is where we really need to be bringing it in. And a lot of things that John mentioned around threat intelligence. I think threat intelligence is a great word, area where, if I know somebody else has been hit first and they're able to share that information with the community beforehand, we can raise our defenses. We can raise that. Security needs to be, I always say, it's like almost like a living organism. It should not be static, and that's the problem we have. Is today security is very static. It's rule based, it's signature based, it's policy based. And what happens is it's not very dynamic to the threat that changes in the world. All of a sudden, when we get a new variant of ransomware or a new variant of malware that's out there, we have, all the vendors have to re-update their signatures. They have to scan it. They also have to know it exists. And therefore, that's where we start. We had that very static process. And for me, getting data into our industry, getting data that can really start to evolve, will allow security to really start becoming a living organism, where it can be very dynamic and adaptive and grow. And when the threats are out there are high, all of a sudden, when we start seeing, the number of companies that becomes victims of some type of variant, we can turn our defenses. We can hit that, threat level up. All of a sudden, that means we can, for example, go from where it's, maybe certain privileges to least privilege, or to zero trust. All of those things can start to be, enhancing the security controls. So that's where I'm really excited about when I get into data. And looking at how we can evolve the industry. Primarily in the current is automation, but in the future, getting security where it's adaptive, and basically where it can change based on the threats out there, and your threat controls can go up and down depending on what's happening. I think that's where we can leverage the data. Also looking ahead as well, looking potentially, when I talked about the hard disk and the memory failures, if we can take that historical data and start putting it ahead, also will give us indications about the evolutions and the ways that threats will come. So it's just interested, John, if you have any thoughts around that, or any comments in that area.
Yeah, I have a lot of thoughts. Let me start with, like, a good strategy is, um, especially when there's such a skill shortage, is have people only do things people need to do. In other words, if a machine can do it, have a machine do it.
Absolutely.
So maybe if you take that strategy and apply it to the machine learning world, you could have a system that's looking at the events coming in, and that system might rate them with, say, a probability of the event being malicious with some confidence score. You think of it as tri-state logic: true,
Yeah.
it's malicious; false, it's not malicious; or I don't know, the other state. And so if you have a system that does that, you're going to want to get the system to be able to rate as many things as it can. You want the system to have ultimate confidence in what it's saying about the event. So in that case, if it's 100%, if the system says I'm 100% confident that it's malicious, then you don't need a human to look at it. If the system says I'm 0% confident that it's malicious, then you need the human to look at it. And then once the human looks at that, the expert looks at that and they label it with something that
Yeah.
goes into the training set, and then that training set informs the next time something similar comes in, and then the confidence begins to increase as humans begin to
Mhm.
label it.
Yeah.
And that's really, really important, the ability to capture what someone says so that a system can learn on it.
So,
But there is
but
also
I have a question before you move on to the next piece. So,
sure.
just on that topic, is that I completely agree with that. Absolutely. If something comes back and it tells me that there's a flag here, um, right now in my mind, and kind of tells me that having a human look at it, it comes down to, I think, when I decide to automate the action or not, it really depends on what that action is. For example, if it's safety related, you have to be very, very 100% certain, doors open, was it let's say machines reboot, roll back to previous snapshots or previous versions, depending on what that action is. So do you think all actions should be automatically, if it's yeah.
Yeah, it's a good question, and I think there's an important nuance here. um and the nuance is there's a difference between automation and autonomy.
Yes.
Autonomy is the system making the decision by itself to do something, that something might be done automatically. And so, for example, you might one of the things you might want to do is isolate a machine
Yes.
as an action, and you can automate the process of isolating a machine. You hit a button, and the system goes and blocks the IP address at the
Hmm.
entry point, wherever that may be. That's automation. Autonomy is the system without human input deciding to automate the machine. And we're not in the cyberspace, we're not anywhere near automation.
Yeah.
We're near autonomy yet.
Autonomy.
And
Yes.
and and you can see that because you could see organizations that have implemented SOAR systems, and the SOAR system is really more about auto- aut- au- automation, not
Mhm.
autonomy. So, for
Yeah.
example, it goes out and collects all the contextual data you need from an IP address or an executable or domain name, what happens. But you don't see those systems actually going out in most organizations deciding on their own
Mhm.
autonomously to block that hash. And the reason is because whenever you take an action in a system, that very action itself represents a risk. And you don't know if you're decreasing the risk or increasing the risk. So, this is also a place that data sciences, machine learning
Mhm.
can really help. And this space is called multi objective
Mhm.
optimizers. So, for autonomy, if you think about autonomous vehicles, there are multiple objectives. Like the first objective is keep the passenger and the driver alive.
Yeah.
The second objective is keep anyone else outside the car alive. The third objective is maybe get to the destination as fuel efficient as possible. And the fourth objective could be get to the destination as pleasurable as possible in terms of the route. Take a route that's more
Mhm.
scenic, as an example. So here are all these objectives. How do you make a decision in the moment given that set of objectives? That's the autonomy of it. So in our
Mhm.
world, we might say, don't take the system down, keep the system up and running. Don't let the threat take the system down, and make a response that is very contained to that
Mhm.
system, and give the system those objectives. The cost of the response should be minimal, as an
Yeah.
example, and list all those objectives out, and then have the system tell you, or have the system execute that particular action. And I think we need that. And
Yeah.
that's to your point around adaptation. That's
Yeah.
real. Like, you're not adaptation, you have to change something to adapt. The problem with doing autonomous adaptation is we don't know if we're introducing more risk than we're preventing. And so being able to model that risk,
Mhm.
calculate that risk, is where data scientists can really help.
Absolutely. No, that's a great point, and it reminds me. I did in the past. I actually worked in the maritime industry, so I actually was working in a lot of the first autonomous shipping. So,
Mm.
so that's where a lot of my experience comes into that data analytics and looking at bike safety systems, and having was it multiple systems to make sure that you had as minimal risk as possible. I just want to bring Kevin back in. One of the things that I'd like to get from Kevin, and specifically around what Cybrary does, in the platform for learning and education. and just interested about data science skills and skill sets, and how are we training them, and how we bring them into the industry, and where are they coming from. So just kind of get an understanding about science, what skills that
Yeah.
they need. How do we
Yeah.
get more into the industry so we can automate and do the things myself and John's talking about? How do we get there?
Yeah.
Can you tell me a bit about what's
Well,
needed? And
sure. And I'll circle back to your main point, but just a sort of a tangential point I think is important, which is, um, if if I were to go back in time and say, hey, what is the roles in a security program look like, and if you were to write them down and kind of put the numbers of people you had, it would, my guess is it probably end up looking like a pyramid. So you had a lot of level one sort of people in your program. You had less, but still a good number of level twos, less level threes, etc., up the stack to kind of your pyramid. And one of the things that's I think kind of interesting is, as we're getting more data science, more machine learning, which is then to your point, sort of leading to more automation, better capabilities to sort out signal and noise. I think what's happening is an interesting phenomenon, which is, there's less, I think, the pressure point, 8 years ago or whatever, when I, started SecureWorks, is all about the getting, level one analysts, getting a level one analyst, never had enough of them, could never find enough. And then how do you keep them sort of, retained and interested in that job? Now it's, I think, a lot of the technology, that automation that you talk about, is doing that level one type.
Yes.
And so now the question is like, hey, I need a lot more level twos, like the work that's actually ending up, with the person with the keyboard is more like level two work. And so it's like, well, where do I get those if I don't have level ones? Like, I mean, that used to be the way we did it, right? We would get level ones, and
Yep.
they would learn, and they would, kind of grow there, and then kind of move into the next step. But it's an interesting kind of thing about, okay, well, how do we create all these level twos when we're not really sort of creating level one? So that's one of the things Cybrary is thinking about a lot, which is, not only how do we get people into the, many, hopefully millions more people into the space to help, but how do we get them with the right skills to not only get the job, but to do the job well and to progress up to reach their full potential? That's kind of one point. The other you're thinking about, which is, I think a lot about this. I don't know if we have the answer yet, but I'm thinking a lot about it with the team, which is, some point, how do the the people in the security program actually interpret this stuff? Like, how do they know how the machine works? Because I've been on a lot of calls with customers, over the years, where they have some pretty basic questions about, okay, well, why did you do this or not do that? And when you hear an analyst try to explain how the system works, you realize that, wow, there's a lot of complexity in kind of, okay,
Yes.
why did something happen or not happen, in that whole kind of chain of things. So I think that there's probably a first step, which is, how do we teach the people about how the machine works? The whole idea of sort of like how it, how things go through the, is it suspicious, is it malicious, maybe yes or no, and the whole way that training sets get built and that kind of thing, so that they really understand and can kind of think about how the system works. Because I think that critical thinking process is really important. So I'd start there with, and then the second, I think, step to that is, as people kind of advance in their careers through the security journey, I think then, how do they start to contribute right back into the machine, right? So in the beginning part, they're working in the machine. I think as their careers advance, it's working on the machine, right? And so how do they start to take what they know and actually build that back into the system to make us all smarter and better? So those are definitely things we're thinking about, how to enable sort of more tier twos without without the benefit of having this giant pool of tier ones, and then how do we help people understand how the machine works and then begin to contribute to it.
Absolutely. One of my concerns is the same as well. Is that when I look at how we moved across, how we even in our industries kind of progress in our careers. We started off, on those front lines. We started off, on the front lines of either it was developers. We started off the front line of support. We started front line of sales and marketing, whatever area we came into the industry, and we progressed through those ranks. But when the first front ranks, are being replaced with bots and automations and help desks that are automated, then how do we replace that missing? I think that might be, actually, to your point, is fueling our gap. Is that those
Yeah.
entry point positions are becoming less and less available, where we maybe should have thought about more about automating the more complicated side of things first, and still
Yeah.
had that flux of people coming in. And I think one of the, when I think about even our current, environment with basically, the way that the pandemic has also made a lot of people working, my traditional way of learning would have been in conferences and networking and meeting people and doing workshops, where platforms online like Cybrary has now become so critical to people's continuous learning, because we no longer have those conferences and events and workshops that were happening anymore. So we still had the fuel, that education and knowledge, not just for the new people coming in, but also the existing people to continually getting that skill sets and knowledge. So I think those are also critically important. One of the things
Yeah.
I'd like to move on to John as well. Another question I've got, and then we kind of start getting into summary and closing up shortly. Is that what about getting buy-in from the executive board and management into these areas? Because I think for me that's always been the challenge: is how do you get to them invest in this? Because people and executives and organizations that their business is not technology. Let's say their business is, manufacturing or transportation or in communications or whatever it might be, or even, in healthcare. How do we get them to buy into, doing the right things when it comes to, let's say, even, security and especially in data science as well? How do we make sure that they invest in this area? Because that's one of the things. How do you convince the board to get buy-in, and who needs to be involved?
Yeah. So, just to be clear on the question, invest. How do you convince a board to invest in security overall, or using data sciences for security, or both?
I think both. I think one
I
is
think
getting
both.
them involved into using data science for security. They might, some businesses might be using it for other areas. And they might already have a data science part of the business. How do we get them to also include that also into the security portfolio, security part of the business?
Yeah, I think if you have a capability in your organization and another part of the business that's using data sciences already, I would leverage that as much as I possibly could. Um, there was a period of time when data scientists, also known as super quants, were really highly focused in the financial vertical,
Yeah.
and I think that probably has gotten a little bit boring. And now, being able to solve a problem where there is like an active adversary on the other side of the table, using data sciences is an interesting pull into into the into the cyber domain. I think the conversation with the board is, and for me, I've always structured it around risk reduced per dollar
Mhm.
spent.
Yes.
And when I look at the board and I say, look, there, we're not going to be able to have zero risk. It's asymptotic. We might be able to approach it, but the cost is exponential. You can reduce half the risk with twice the amount of dollars. So when you go to the board and you kind of look at the problems, you highlight the problem that could reduce the greatest amount of risk with
Mhm.
dollars spent. And if there's an opportunity to do that with data sciences, then I think that's how you position it. If we take a look at, the modernization of this approach, we build out a tech stack that isn't just sort of query based, but it's could be graph based and event based and stream
Mhm.
based. And you don't use those words to the board, of course, but if we update our stack, we think we can, reduce the risk twice, proportional to
Mhm.
the amount of cost. And so, like, that's generally how I would position any kind of project from a security perspective.
Absolutely. It reminds me, I did a penetration test quite a few years ago now on a power station. And when I went with the CISO and we went to the board to do our present our findings, we presented fear. We presented the traditional, feedback of security, into the executive board, and it didn't work. The CEO was a smart person. The CFO was smart. They came back and said, you scared us. That was a really scary presentation, but we need to see the investment. We need to see the return on investment. We need to see the benefits to our employees. And it was always a thing, when I sit down and they said they need to see tangible return on investment. They need to see something of impact. And to your point, one of the things that I always remember what the CFO said to me: I need to know, what is the cost of doing nothing versus the cost of doing something. What is that? What's that gap? Is that gap 10%? Is that gap 90%? And that ultimately indicated they're willing to invest a certain proportion to reduce the risk. And sometimes they might have decided we'll go and do cyber insurance, we'll go and do a cyber captive, or we'll just do better, awareness training, or we'll invest in technology, or we'll do a
Sure.
combination of multiple things. And that typically that really indicated their decision making. And that really realized to me, and to your point, is that we need to be understanding my job is to reduce risk and is to listen to the business, understand what their goals are, understand what the risks are, and then find ways in order to use my skills and knowledge to reduce risk. And that's ultimately how I see my position is I'm a risk reducer. That's ultimately where I spend my time. So it's just kind of getting into some of the things, are you optimistic that we're making the right, are we advancing, in the right direction quickly enough? Is there things that we can do in order to do better at this, or is there ways that we can accelerate, or also show success? I think one of the things we don't do enough is showing where it's been successful as well. Sometimes people don't like to do that because sometimes it points a target on the organizations when they do that. So I'm just interested, both Kevin and John, just kind of what's next, what's the direction, and what can we do better?
Yeah. Well, I think to answer your question, are we doing enough? It seems like there's a lot. There's absolutely a ton, going on. If I just look at the, sort of the number of,
Mhm.
of startups, for example, and the money going into some of the problem space, it feels like, um, there's a lot there. I think, to your point of, how do we, um, bring some of those things more to mainstream, maybe
Mhm.
faster. I think part of, this idea of confidence, maybe there's a little bit more we need to do in the area of confidence,
Mhm.
because this idea that you have of taking an action, taking that next step of, all right, let's move it, more, from the benefits of automation into more the benefits of, like, let's say, self healing, or
Mhm.
autonomously
Mhm.
doing things. I think all has to do with confidence. And back to that thing, it's like, okay, am I, by doing this, am I creating a bigger problem or a bigger issue
Okay.
than by not doing it?
Mhm.
And I think there probably is more that could go into that, to give us better visibility, and ultimately confidence that actually taking that action is the right thing. All right.
Mhm.
Like, we know that taking that action does have some risk, but a system that could tell us that it's a good risk, right? That it's the right risk to take for the organization
Mhm.
based on knowing what the outcomes of it could be, or predicting the outcomes of it,
Mhm.
the likely outcomes. So I think that's an area where it's like building confidence so that we can actually make this next big progression is a pretty important thing. That maybe there's, things out there we could do more
Mhm.
there. Um, I'll just one thing back on the, talking to the boards and
Mhm.
executives. Never underestimate the value of a data scientist that you would like to go have a beer with. With that personality of somebody that can, just sit down and say,
Mhm.
let me kind of talk you through it. And I think we need to do something. Maybe that's our Cybrary's next thing. Like,
Mhm.
how do we create, more data scientists that are interested, that are great conversationalists, right? Great
Right.
educators, for people who aren't data scientists. That's If you have somebody like that in your organization, you should put a bubble around them, wrap them,
Mhm.
in a
Embrace
bubble
them.
wrap, and protect them.
Embrace
Yeah,
them as much as
yeah,
possible. Yeah,
yeah.
because you remind me absolutely that the CFO during that pen test was the data scientist. He was the
Mm.
person that kind of really bridged that gap. And he's a financial background, so he knows all about tangible and about data, about budget and so forth. And that was a big impact. So, John, just kind of any thoughts around that as well, and any final kind of words, or kind of for the audience, what are we moving in the right direction? What can we do to get better?
Yeah, I think we're absolutely moving in the right direction. Are we moving in that direction as fast as we need? Maybe not, but I'm very optimistic. The people who defend our way of life, take it seriously, and it's, to many of them it's personal, and I'm thankful for them and the work that they do. I do want to see the impact of sort of data sciences, if you will, on cyber increase. And I think
Mhm.
one important aspect of that is We have to get to a position where we can sort of learn globally and infer locally. So being able to take lots of data feeds from lots of different places, build models on those, run inference algorithms and learning on them, and then push those learnings out to the endpoints so that we can collectively defend and learn from one
Mhm.
another. And that was always been sort of the promise of threat intelligence. But I think data sciences and really kind of this edge computing model that's emerging
Mhm.
will really help us. The other thing I would like to leave the audience with is having built a lot of systems and machine learning. There are a couple things to think about that I've learned that I would like to share and hopefully help progress your efforts. And the first thing is you're going to need a team of multidisciplinary people. You're going to need the security subject matter expert. You need a data scientist, a super quant, someone who understands, the math behind the means. You need a developer, someone to codify it and to get it to scale. And you need a data architect and a systems architect where you need to get the systems to scale, not just the solution to scale. And so, any effort that I look at, I always have a multidisciplinary team that includes at least one or multiple of those kinds of skill sets. And then we prioritize. We prioritize in this order. First of all, iteration in speed is really critical. There's no free lunch. You're going to have to
Mhm.
continuously to evolve the models and the algorithms and the learning approaches and the data and the features and everything that goes in. So be able to iterate quickly, make sure you have a system that you can iterate on. If your iteration cycles depend upon a code release cycle that, even in a 2-week sprint, you're not going to get there. It has to be rapid. The second thing I would say is scope the problem. That's the single most important thing when it comes to being
Mhm.
able to get high efficacy. And in scoping the problem, you want to make it as small as possible and have a clear determination of what right looks like. The third thing would be rich data and simple algorithms. If you have if you have to modify an algorithm because you don't have visibility into
Mhm.
something, you're missing a piece of data, go get the data. And that's why, just as an aside, you see the endpoint detection and response space exploding because all of these analytics used to be based on network data, but we didn't actually see what was occurring on the endpoint. Get the data and simplify your
Mhm.
algorithms. Rich data, simple algorithms wins the day every day. And then feature selection is critically important. Feature selection is the pieces of data that you use to in the model that help drive the outcome of the model. The feature selection is a hard part. To me, that's still very much the art of it, and that's where the subject matter expert needs to come in and provide the domain
Mhm.
context. And then the inference algorithm itself, which everybody thinks is like the most important thing. Like, is it naive Bayes, or is it mini max, or is it expect a max, or is it q learn? Like, all of that, honestly, like, that's the easy part. That
Yeah.
it's hard. It's the easier part of everything. So that just sort of a playbook, if you will, on
Mhm.
how to go out using machine learning data sciences with a cyber problem.
Absolutely. I think you're spot on with all of those. For me, you hit on a point that kind of brought home to me as well as, make sure you focus on the problem. Sometimes the solution becomes the focus, and
Yeah.
that sometimes puts you down the wrong path because then you forget what you actually were originally trying to solve. So that's a major area. Data veracity is key. Having the veracity of the data is so important. I will say that um, knowing the right questions to ask and having the data can help you answer those questions is one of the most important. It's the recipe to success, especially in this area. If you know what you want, the questions to ask, and you have the data that can give you those answers, then that's the key recipe and the foundation to help you get there. It's been fantastic. It's been a pleasure having you on the show, and I think this has been really educational for the audience. I think this is an area which is growing. An area, if anyone's listening, that you're interested in cybersecurity, or you're interested in even getting into, if you're a data science background, or even in cybersecurity, you want to learn more about data science, definitely this is a show that hopefully you got a lot of value from it. So, Kevin, John, it's been amazing having you on the show. Look
Yeah,
forward to having
likewise.
more discussions with you. And for the audience, this episode, 401 Access Tonight, is all about data science. Tune in every 2 weeks for the next episode. Subscribe to make sure that you continually get updated. And John, Kevin, it's been fantastic. Thank you.
Thank you, Joe.
Thank you.
Thanks, Kevin.
Yep, thank you.